Hello guys, this is your lesson on trig identities. So we're going to list all these out and practice using them. It's a lesson that's very much based on memorization. So first, let's list them all out. First, we have the reciprocal identities, which a reciprocal just means you're going to flip something over. So these, you really know them already. We're just going to like officially write them out. So 1 over sine is going to be cosecant. We put theta in there. Theta represents the angle. So I don't always say sine of theta because it's a mouthful, but 1 over sine is cosecant. Those are reciprocals of each other. So 1 over cosecant equals sine. You guys have already known sine and cosecant are reciprocals, just like writing it out in an official way. And so cosine and secant are also reciprocals. So 1 over cosine is going to equal secant. 1 over secant is going to equal cosine. And then tangent and cotangent are reciprocal. So 1 over tangent is going to equal cotangent. 1 over cotangent is going to equal tangent. I wouldn't try to memorize those as 6 totally individual things. You really already know that. We've already covered that. We've talked about how to get cosecant is you take sine and flip it. Again, we're just sort of writing it out in an official capacity. All right, quotient means a fraction. You're going to have something over something else. I'm going to draw out this triangle just to illustrate this a little bit. So, here's our right triangle. Here's our angle theta. We're on the unit circle. The radius is 1. It's 1 unit. This is our x dimension, this is our y dimension, and x is cosine of theta, and y is sine of theta. That's how we get those values from the unit circle. Cosine is x, sine is y. So when you do a quotient, something over something else, if you do sine over cosine, that's going to give you tangent. Tangent is opposite over adjacent, or y over x. So sine over cosine is going to give you tangent. Tangent was y over x, sine over cosine. And then for cotangent, since tangent and cotangent are reciprocals of each other, if you just flip that over, you're going to get cotangent. So cosine over sine gives you cotangent. And these are also true if you square them, because you sometimes see that in the problems that we're going to do. So just for the sake of being really thorough, if you square these, it's still true. So like if you had cosine squared over sine squared, that would be cotangent squared. And same thing for this one. If you had sine squared over cosine squared, that would be tangent squared. You can square those and it still means the same thing. Here, I'll write that one up too. Because if you see it squared, it still means the same thing. You just have a squared in there, that's all. All right, next are the Pythagorean identities, which come from the Pythagorean theorem. So first one would be sine squared plus cosine squared equals 1 squared. So we're just using this triangle to do the Pythagorean theorem. So sine squared plus cosine squared equals 1 squared, which just is 1. Now there's 2 other versions of this, and you get them by doing the, we're going to use the reciprocal functions in there. The first one you get by dividing every term by cosine squared. So here, I'll write this off to the side. If you divide through by a cosine squared, that's going to give you the other, like the next version of this identity. So sine over cosine, we just said was tangent. Again, they're just squared. So that would be tangent squared. Plus, all right, anything over itself is just going to be 1. And 1 over cosine squared. Well, we said 1 over cosine is secant. Cosine and secant are reciprocals of each other. So 1 over cosine squared is secant squared. And then to get the third version of this, we're going to divide through, I'm just writing that out again. This time we're going to divide through by sine squared. If you don't want to write all this out, you don't have to. I'm just doing this by way of explanation for where this is coming from. So we divide through by sine squared. Anything over itself is 1. Cosine over sine is going to be cotangent. It's just that it's squared. And then 1 over sine is cosecant. Sine and cosecant are reciprocal. So 1 over sine squared is cosecant squared. So I only ever really memorize the first one. And then I just know I can divide through by either cosine squared or sine squared to get the other two. So I only really memorize this one. And then I just know I can get the other two. All right, even and odd identities. This comes down to which of the trig functions are even and which ones are odd. So odd means that you've reflected across the origin. So if you plug in a negative angle, you're going to get the negative trig function. So sine is an odd function. Sine of negative theta is going to give you sine of theta. And it's going to be the same for cosecant. Keep writing that. So cosecant of negative theta would give you negative cosecant of theta. And the same for all the other odd ones. So those are all the odd ones. If you plug in a negative angle, you're going to get a negative result. The even ones, even means that you've reflected across the y-axis. So if you plug in a negative, you're going to get the positive version of it. It's just going to be on the other side. So cosine and secant are the two even ones. So cosine of a negative angle, that's just going to be cosine of theta. You're going to get the positive result. And so same thing for secant. So the odd ones are negative, the even ones are positive. Is all that is. And then we have the cofunction identities. This one does throw people off. You just have to be really, really careful because we end up in our minds like linking sine and cosecant together and secant and cosine together because they're reciprocals. This one is cofunction. So sine is going to match up with cosine and secant is going to match up with cosecant and then tangent's going to match up with cotangent. They're the cofunctions. You're just like adding or removing a co. So I'm going to write out the first one and then I'll kind of draw a triangle to explain where it comes from. So sine of 90 minus theta is going to be cosine of theta. Cosine of 90 minus theta is going to be sine of theta. So when you see that 90 minus theta in there, that's the cofunction identity and the co's go together. So sine goes with cosine, cosine goes with sine. Here's the reason why this is true, like why this works. So here's your triangle. Here's theta. Let me just make up like a triangle. Like it's easier if there's actual numbers in it. Like say this is 3, 4, 5. So if you do sine of theta, that's opposite over hypotenuse. That would be 4/5. This angle up here is 90 minus theta. These are going to add up to be 90 because the whole triangle has to add up to 180. If this is a right angle, these have to add up to 90. So if that one's theta, this one's 90 minus theta. If I do cosine of 90 minus theta, so like this angle is now my point of view, cosine is adjacent over hypotenuse, which would be 4/5. So they come out the same. So that's like the reason why this works is because if this angle is theta, this one's 90 minus theta. So the cofunction is going to be the same. So tangent and cotangent go together. Tangent of 90 minus theta is going to be cotangent. Cotangent of 90 minus theta is going to be tangent. And then secant and cosecant go together. So secant of 90 minus theta is cosecant. And cosecant of 90 minus theta is secant. Now you're probably like, why'd she do them in that order? The reason why I did that is because I printed on the other side of here what these are. And so what you've just created is a set of flashcards. If you want to cut them out and use them as that, like we made a set of flashcards. So I had to put them where they matched up with on the other side. So like if you're looking at this side, then you can, flip it over to get the answer. So like sine over cosine, that's tangent. So if you flip it over, you're like, oh, sine over cosine is tangent. So you can use this as flashcards if you want to cut them out. All right, so now we're going to use all of those identities to answer questions. This is really like puzzle doing. Like if puzzle doing appeals to you, this is going to sort of be your thing. It is very, like you have to memorize those and just use them. So it is sort of dry. You're going to do a series of replacements. So you replace something with something else. And the idea is you want to try to get something to cancel and simplify it down. Simplify means like make it look more simple than it did before. When in doubt, you want to change everything to sines and cosines. So change everything to sines and cosines if you can. So like for this one, I'm going to replace tangent with sine over cosine. So I'm taking the tangent out, I'm replacing it with sine over cosine, because we know tangent equals sine over cosine. So I'm replacing it with that, and then times cosine of theta. So what happens there is the cosines cancel and you just get sine, and so that's your answer. So again, you're trying to take what's there and make it simple. That's what simplify means. You want something to cancel out so that it gets simpler. So same thing with this one. We're going to replace tangent with sine over cosine. And then that's all over sine of theta. And actually, I'm going to put that over 1, because when you divide by a fraction, I know you're like, there's so many fractions in there. When you divide by a fraction, you multiply by the reciprocal. So we're just going to flip that over. So it'll be 1 over sine. So then the sines are going to cancel. We get 1 over cosine. And your reciprocal of cosine is secant. So secant of theta is our final answer. Right here we have the cofunction identities. Whenever you see that 90 minus theta, it's cofunction. So secant's cofunction is cosecant. So secant of 90 minus theta is cosecant of theta. Minus, and then this is cosine, the cofunction for that is sine. So sine of theta. Now, we can't put those together because they're not like terms. When in doubt, you want to write everything as sines and cosines. So I'm going to rewrite this cosecant as 1 over sine. And actually, I'm going to go ahead and write the sine of theta over 1 as well. In order to add and subtract fractions, you need a common denominator. So we're going to make both of these have a denominator of sine of theta. So this one, I'm just going to multiply by sine of theta in the numerator and the denominator. So this is like algebra here. We're, trying to put the fractions together. So in our numerator, we're going to have all of this put together. So our numerator, the idea is you're trying to put the two fractions together. It'll be 1 minus, and then sine times sine would be sine squared, and then over our common denominator. Now, whenever you see a squared in there, you want to think of the Pythagorean identities. So let me pull out the other sheet real quick. So we have 1 minus sine squared. If we look at this identity here, if I subtract this sine squared to the other side, I'll have 1 minus sine squared, and that will equal cosine squared. So again, if I subtract this over, I'll have 1 minus sine squared, that'll equal cosine squared. So I'm going to replace this with cosine squared, which actually I'm going to write, well, here, I'll write out the middle stuff. I'm replacing that with cosine squared. And I'm going to write it as cosine times cosine. That's what squared means, is that you have 2 of them. Because now I can do one more replacement. Cosine over sine is cotangent. So cosine over sine is cotangent. So we get cotangent times cosine. And you're probably like, how on earth is that any better? Well, we don't have 2 separate terms anymore separated by a subtraction. We've combined it together into one term, cotangent times cosine. All right, whenever you see the negatives in here, those are your even and odd identities. Secant is even, so it's going to turn positive. So this is just going to be secant of theta. Cotangent is odd, so it's going to turn negative. So that's negative cotangent of theta. And when in doubt, you want to change everything to sines and cosines. So secant, we can replace with 1 over cosine. And actually, I'm going to take this negative and put it out front, because this is all one big term being multiplied together. So I'm just going to put the negative out front. And then cotangent, we can replace with cosine over sine. So then the cosines cancel. We have negative 1 over sine. And the reciprocal of sine is cosecant. So negative cosecant of theta. Right here, I see squareds. Whenever you see the squareds in there, you want to think of the Pythagorean identities. So we've got a secant squared and a tangent squared in there. It's secant squared minus tangent squared. So if you do secant squared minus tangent squared, if you subtract this over, that would equal 1. So secant squared minus tangent squared equals 1, and then plus 1. Actually, you just end up with 2, which is sort of cool. Here again, I see all these squared, so we're going to need the Pythagorean identities. We have sine squared plus cosine squared. I realize they're not right next to each other, but we're just adding those together. So sine squared plus cosine squared is 1. So those parts I circled we're replacing with 1. And then 1 plus tangent squared equals secant squared. So that is our final answer. All right, here I have 1 plus sine of theta, that whole quantity squared. That means that I have to multiply it by itself. This is FOIL, first, outside, inside, last. It's been a while since we've done this, but I would just write it out twice, and then I've got that plus cosine squared at the end. Basically, you're just distributing everything together. So 1 times 1 would be 1. The outsides give you 1 sine of theta. The insides give you 1 sine of theta. So together, that would be 2 sine of theta. And then the last sine times sine would be sine squared. And then I've got this plus cosine squared at the end. So sine squared plus cosine squared is 1. And then 1 plus 1 gives me 2. And then because both of those terms have a 2 in them, we can factor out the 2. So if you factor out the 2, you would be left with 1 plus sine of theta. So again, it's a series of replacements. And the idea is that you want to make it more simple than it was before. When in doubt, change everything to sines and cosines and then look for something that cancels out. So that was simplified. These ones say verify, which is actually better in a way because your answer is on the paper. You're given these 2 statements that are equal. What you do is you start with one side and you mess with it until you get the other side. You want to start with the side that's more complicated. In this case, that would be the left side because we've got the addition in there. Anytime you're adding and subtracting 2 terms together, that's the more complicated side. So you start with the more complicated one. You want to make it look, basically simplify it exactly like we did on the other side. So I'm going to change this to sines and cosines. Cotangent, I can replace with cosine over sine. And tangent, I can replace with sine over cosine. Now, we're going to do the same thing we did on one of the problems on the other side, which is get a common denominator. So your common denominator is going to be sine times cosine. So this one, I'm going to need to multiply by cosine. And this one, I'm going to need to multiply by sine. Basically, you're multiplying them by each other. And then we can put everything in the numerator together. So cosine times cosine would be cosine squared. Sine times sine would be sine squared. And then it's over our common denominator. All right, and then the numerator, we can replace that with a Pythagorean identity. Sine squared plus cosine squared equals 1. And when you have 1 over these, that means the reciprocal. So 1 over cosine is secant, and 1 over sine is cosecant. And that is what the other side of the equation equals. So you just start with the more complicated side, simplify it down, and your answer is right there on the paper, which is nice. So for this one, the more complicated side is definitely this one. What we want to do is clear out that denominator. We're going to multiply by the conjugate. It's been a while since we've done that, so I will remind you. Your conjugate of 1 minus sine is 1 plus sine. And again, the idea is that you want something to cancel. You want something to go away because there's no fraction over here. So we have to make the fraction clear out somehow. So the numerator, you can distribute that, I guess. I'm just going to leave it alone. Because again, the idea is I want something to cancel. So if you leave it factored, you're better off. So just leave that separate. Denominator, we're going to do FOIL. So first, outside, inside, last. So 1 times 1 is 1. The outsides give you sine of theta. The insides give you negative sine of theta. So the outsides and insides cancel, which is kind of the whole point. And then the last, negative sine times sine will be negative sine squared, which we can use a Pythagorean identity for that. 1 minus sine squared. We're going to use this one right here. If you subtract over the sine squared, 1 minus sine squared gives you cosine squared. So I'm going to replace that denominator with cosine squared. And then the cosine squareds are going to cancel, and you get 1 plus sine of theta, which is what the other side of the equal sign was. So again, you start with the more complicated side. You want to make it look like the simpler side. So down here, last one, this is definitely the more complicated of the sides of the equal sign. I would start with the denominator, 1 minus secant squared. So looking at the Pythagorean identities, Now this one, we would kind of have to like mentally rearrange this because it's 1 minus secant squared. So if you subtract over the secant squared, you'd have 1 minus secant squared, but you'd have to subtract the tangent squared to the other side as well. So to get 1 minus secant squared, you would subtract the tangent squared over. So that denominator is going to be replaced with negative tangent squared. And then what I would do is separate this. We're going to put the sine squared over the negative tangent squared, and then the negative tangent squared over the negative tangent squared. And actually anything over itself is going to be 1. So I'm just going to change that to +1. You can write it out, I guess, if you want to, but anything over itself is going to be 1. And even the negatives cancel. Negative over negative is going to cancel. So that'll actually just be +1, which is sort of nice. Now, when in doubt, you want to change everything to sines and cosines. So I'm going to replace this tangent squared with sine squared over cosine squared. So again, tangent is sine over cosine. It's the same thing if you square it. It would be sine squared over cosine squared. Oh, and then +1. So whenever you divide by a fraction, you're multiplying by the reciprocal. So we're just going to flip this over. So dividing by a fraction, you multiply by the reciprocal. The sine squareds are going to cancel. So you have negative cosine squared +1. And again, whenever you see the squareds, that's a Pythagorean identity, negative cosine squared +1. So if you subtract this over, you will have negative cosine squared and then +1. So you can replace that with sine squared, which is what it says the answer is.